From today, what we are going to do is, we are going to start with the real fundamentals of electronics experiments. But before going on to the experiments, we need to know what are all the equipments that are going to be used, especially in the GTTC where you will be deployed in the various centers. Okay, so as part of that, we are going to learn about the regulated power supply, the function generator, as well as about the oscilloscopes. Okay, so that is what is the agenda for the day. Hope we complete all these three working, so you also get hands-on how to use those equipments and all that. By end of the day, all these three equipments should be done. Now, how versatile are you with using your digital multimeter? Did you get exposed to using the DMN, your digital multimeter? What are all the options available? What all the measurements could be done? Okay. Of course, for these experiments also, we will be making use of the DMM also. Okay. So last few days, what have you been doing is, you were learning about your circuits. Say last class you had some series circuit, parallel circuit and all those things. So now let me take this as a black box. So imagine I have a circuit. Okay, I have a circuit. To this circuit, I need to give something called as the input, and it will give me an output. This circuit, it's going to be constructed making use of, say, your active or the passive components. Now, what are the active components that you know? Diodes, transistors. So, in transistors, all your BJTs, FETs, all those things will be your active components. So, here you have, say, diodes, your transistors, etc. Now, when I come to the passive, what are my passives? Your RLC. Generally, we call it as our RLC. That is our resistor, capacitor, and then the inductors. So, making use of this, we construct what is called as the circuit. Now, this circuit has to be provided some input, and effect of that, it will produce some output. Now, what are the devices that can be used for giving the input to your circuit? So, the main one is your DC source. The other could be your AC source. So, for DC, what do we use? We make use of our regulated power supply. Okay. So, for DC, it is going to be your RPS, which we call it as the regulated power supply. Now, what is DC first of all? Direct current. And AC is your alternating current. Hope all those fundamentals has been taught to you. Now, for AC source, what could be the AC source? What could be the AC source that we can use in the laboratory level? Your function generators. Okay, you can make use of your function generators. So, based upon the circuitry, it could be a DC signal that's given, or it could be an AC signal that's provided to your circuit. Circuit does some function, and in turn it will produce the output. That output has to be viewed by us. It has to be validated by us as we are doing the experiments. So, to validate that output or to observe that output, we make use of the measuring devices. Okay. So, for output, we make the measuring devices we make use of. So, what could be the measuring devices that comes to your mind? Voltmeters, ammeters, then wattmeter, then Okay, which does all these functions is nothing but our multimeter. Then, so if it is going to be a AC or DC signal, depending on that, I can make use of an AC voltmeter or a DC voltmeter, respectively. If it is an AC signal, I can make use of an AC ammeter. If it is a DC signal, I can make use of a DC ammeter. If at all I am using a multimeter, then I have to switch between my AC mode and then the DC mode. All that I think you are exposed to it. Next, if it is going to be a pure AC signal that's coming from my function generator and it's going to be in the form of say waveforms, what is that? I'll be using as my measuring device? Oscilloscopes. So I make use of what is called as the oscilloscopes. So in this oscilloscopes, you can have your CROs or it could be your DS. And your DSO is nothing but the digital storage oscilloscopes. Okay, so digital storage oscilloscope. I think in your labs, have you ever used the DSOs? Any of you? During your course of study, have you used the DSO? No. So all of you, I think, would have made use of CRO, which is nothing but analog oscilloscopes. But in all our GTTC centers, we have only the DSOs. That too, it's a 4-channel. Of course, there are 2-channel DSOs, 4-channel DSOs. So almost all of the centers are provided with 4-channel DSOs. Okay. So now what is that we are going to learn in today's sessions is, we will be learning about this DC source, which is nothing but my regulated power supply. What are the different variants? Okay, some are with say supply like this. Some are given with the programmable power supply. So how to handle them? So that we will be learning. And also we will assemble a small circuit. As you have learnt about the series and parallel circuits, we will assemble a small circuit, make use of a multimeter, try to measure the current, try to measure what is going to be the voltage. All those things we will do. Once that is done, then we will get familiarized with the function generator, the various types of function generators that are there in the GTTC centers. And finally, about our digital storage oscilloscope, the 4-channel DSO. Okay, so this is what we are going to do now, and hope you understand. The sources are nothing but it could be my DC or the AC. So DC, I make use of the regulated power supply, and for AC I make use of the function generators. So function generators as it is in the laboratory level, and I make the measurements by making use of either my multimeter or my oscilloscopes. In the oscilloscopes, preferably I go for the DSO because all of the centers are provided with the DSOs. Okay. So now let's start with our regulated power supply. Slide. No, I wanted to erase on the.
Slide below. Slide to the below one.
Oh.
The red icon just above. Slide.
Okay. So this we generally call it as RPS, the regulated power supply, which is going to give me my DC signal. Now first let's learn the block diagram of this RPS. What will be the different blocks in it, and then we will go for the actual setup, how it is. So in simple to say, these are the various blocks. Of course, it's much beyond that, but simple. In simple block diagram level, if you see, there are 4 different blocks. Step down transformer, then you have your rectifier, followed by filter, followed by the voltage regulator. Now, to the step down transformer, the input is given normal AC input. What is the AC input here in India? 220 generally we say 220, and the frequency is 50 hertz. Okay, so 220 volt, 50 hertz AC signal is provided to my step down transformer. I think transformer types, there are 2, step up and step down. So here step down was, what does it do? It reduces it from 220, probably say 15 volt or 18 volt or 12 volt, it steps down. So here I may get a lesser voltage than the 220. Let's say I have some 15 volt. What is the nature of this signal? This is also still AC, but with a frequency of 50 hertz, and the voltage level is 15 volt. Okay, so still it is a AC signal. So what do I have here? If I put it in the diagrammatic representation, I have a 220 volt AC signal with a frequency of 50 hertz given as an input to my step down transformer, where it gets reduced to say 15 volt at a frequency of 50 hertz. Now this is given as an input to my rectifier. Rectifier, what does it do? Converts AC to, you should not term it as DC. It is pulsating DC. Okay, because at a stretch it doesn't convert all my AC signal to DC. So what does it do? It converts AC to a pulsating DC. So what is meant by pulsating there? It means along with my DC signal, there are also some AC signals present, which I call them as ripples. Hope you are able to recall. You would have studied that. Ripples, what are ripples, ripple factor and all that. So along with your DC, the converted DC, you also have some AC signal, which is nothing but my ripples. So what is my aim? I have to get rid of all those AC. I should get only the pure DC at my output. Okay, so this 15 volt from the step down transformer is given to my rectifier. Now once again, if you take this rectifier, it could be of various types. What are the types? Half wave rectifier, full wave rectifier. Half wave and full wave. In the full wave, once again, we have 2 different ones, which are nothing but the center tapped and then the bridge rectifier. So half wave rectifier, what does it do? All those things we'll be studying in the next few days. And we will also assemble the bridge rectifier, and then we will be making the power supply as such. So basically what the rectifier does, converts your AC to a pulsating DC. So now what do I have here as the output is a pulsating DC. So what does it mean? My signal is going to be something like this. Suppose if I have used a full wave rectifier, right? It will be in only unidirectional, one direction, but with all the ripples. Okay, with the sinusoidal component still present, or to say my AC signal still present along with my DC. Now this is given as input to the next block, which is nothing but my filter. So what does the filter do? It removes those AC signals, or to say it removes all those unwanted AC signals which are nothing but my ripples. Okay, so the main job of the filter is to remove your unwanted AC ripples. So what do I get here after filtering? A DC, but that DC will be an unregulated DC signal. Okay, at the output I will have a DC, but it will be a unregulated DC signal. So now rectifier, I've given to a pulsating DC. I get the pulsating DC, which in turn is given to your filter. Filter, what does it do? It filters out. I'll be having the DC component, but that will be a unregulated DC component as such. So my pulsating DC will be something like this. Okay, this is my pulsating DC, and here I am going to have my filtered DC signal. So slowly, depending upon the value of the filter that I am going to use, I may achieve something like this. But what will happen? It will be an unregulated value. It will be an unregulated in the sense I will not have the constant voltage there. It will be changing. Say I want a 5 volt DC or a 10 volt DC. I will not be having the exact 5 or 10 there. There will be variations. Okay, so from pulsating DC, I get an unregulated DC output as my filter output. So here I have my unregulated DC. Now what could be the components that can be used for filtering? A capacitor. You can make use of your capacitor or your inductor also, and combination with the resistor. Okay, so generally all the three passive components, they can be used for the filtering. I can have an RC filter, I can have an CLC filter where I have a combination of capacitor, inductance and then a capacitor. So I can make use of capacitor, an inductor, or a combination of a resistor and capacitor, or a combination of say capacitor, inductor and then a capacitor. Like that I can have the combinations and use those components for filtering my pulsating DC. Clear till this? Okay, so generally what we do is we prefer capacitor because inductor will be bulky by nature. Okay, so we prefer the capacitor as the filter component. Then now it's filtered, I have my unregulated, but what I want is a regulated DC signal. So what do? I give that as an input to a voltage regulator. The output of that voltage regulator will be a regulated constant DC signal. Okay, so here I have a regulated DC signal. So my output will be like this. Say if it is say 10 volt, I'll have it at 10 volt level, or if I'm using say a 5 volt, I'll have it at the level of 5 volt, or if I want some negative voltages also, I can go for some say minus 9 volt, like that I can have a various values. Now regulator, what are all the components that can be useful for your voltage regulations? So when I talk about regulator, which component comes to your mind?
7805.
7805. If I am using an IC regulator, 7805. If I am using a diode, Zener. The main application of our Zener itself is it's useful for the voltage regulation. So I can have Zener voltage regulator or transistor based regulator. Then also I can have, as he told, 7-8 series or 7-9 series, which we call it as basically fixed voltage regulators. So in fixed voltage regulator, as we were discussing, we have two series. One is 7-8 series, another is 7-9 series. 7-8 series will always give me positive voltages. Okay, it will give positive voltage, whereas 7-9 series will give me negative voltage. When I say 7805, 7805 will always give me plus 5 volt. When I say 7908, 7908 will always give me minus 8 volt. Right? So 78 is for positive voltages and 79 will be for your negative voltage. I've just written XX. XX is nothing but the value. I can have 05, 08 or 1, 2, like that various specifications I can have. Okay. So this is Zener I can use, transistor based regulator. I can go for fixed regulator. But what is the disadvantage with the fixed regulator? It always give me only one value. Imagine I want a range of values. I want to have values from say 2 volt till 12 volt or 2 to 24 like that. So what do? I go for the variable. I go for my variable IC regulators. Okay. So that one is nothing but what you will be doing as a project also, making use of your LM317. So I can use the variable IC voltage regulator, where specifically we'll be making use of LM317 IC. Apart from all these things, what comes to our mind whenever I talk about regulator? You can use your SMPS. So SMPS is nothing but your switch mode power supplies. Okay, so each has its own advantages and disadvantages. When I go for Zener, okay, it gives me a voltage, but the regulations will not be good. Regulation in the sense my line regulations and then the load regulation. Same thing applies for your transistor. When I go for a fixed voltage, I get only one particular value, either 5 volt or I have channel 1, channel 2 and channel 3. And here you have the on and off button, right? Channel 1 you can see the rating, it is given 0 to 32 and what's the maximum current here? It is 3.2 ampere. Similarly for channel 2, 0 to 32 and the current rating is 3.2 ampere. So there it was 3, now it's going to be 3.2. Voltage wise it's the same. Then you have here the channel 3 which is capable of giving you from 1.8 to 5 volt. So 1.8 to 5 volt and here you have the options for it. It can be 1.8, it can be 2.5, 3.3 and then 5. So this is basically for your TTL logics, CMOS logics when you are using your digital ICs. Okay, so you have 1.8, 2.5, 3.3 and 5. So this will always give me a constant value. I cannot vary it. When I'm using this particular port channel 3, I cannot vary. Depending on my selection, either I will get 1.8 or 2.3 or 2.5 or 3.3 or it is going to be 5 volt. So constant value will be got over here. Whereas channel 1 and channel 2, depending upon how I vary, I will be able to get from 0 to 32 volt. Okay. So here you have here, I think the complete picture is in there. This is for channel 1 and this is for channel 2. If I want to view the voltage, I have to press this V button. If I want to view the current, I have to press this I button. Then you have here OVP. What does it mean? Over voltage protection. So when it crosses the limit, then what will happen? Immediately it will safeguard your device as well as your circuitry. So you have your over voltage protections there. Now if I want to set the value, this is the display where I will be getting the display. Whatever I set, the voltage or the current, it will be displayed here in the screen. So if I want to set the value, I can directly key in with these buttons or I can use this rotary. I can use the rotary and then I can set the values there. And also if I can view all the channels at the same time. The values will be displayed here, voltage value, the current value and all that. I can use all of them at the same time by pressing all. Or if I want individually channel 1 or channel 2 or channel 3, then I can use any of these buttons. Okay, so it's all self-explanatory. Now if I want to use these values here, then I have to make use of the shift button. Imagine I want to set 5 volt. Shift and then press this, I'll be able to get a 5 volt. Shift and press 1, I'll be able to get a 1.8. Where will I get? In which channel will I get? Channel 3. That is where I will be getting the fixed voltages. Okay. So rest all, I think it will be beyond. This much is enough right now. Also, you have other parameters. Right now, it's not required. Okay. So this is the another type that are there in the GTTC centers. So now what we are going to do is we will get used to both the types. Okay. And also I want you to rig up a circuit with your breadboard, a series circuit. Say you can take two resistors, provide a DC supply, measure the current, measure the voltage across each of the resistor. I will only give you the circuit, you can do it, or you can take your own circuits. Better I will give the circuit so that it will be easy for you. So first you get familiarized with the power supply. So familiarization is first what you are going to do. Second, what you do, you rig up this series circuit. And what you are going to find out is, let's say R1 and R2 I have. Let me take some 2.2K and let this be 1K. Right? Let's say I give 10 volt from my power supply. I want you to find out what will be the voltage across R1, voltage across R2, what will be the current, let's say current I, what will be the current in the circuit, right? So now what will happen, I will understand the usage of the regulated power supply. To find out these values, I have to make use of my multimeter. So I will understand the usage of the multimeter also, and how do I rig up the circuit and use the breadboard. So all those will be satisfied if I try to rig up and find out the values. Clear? So two things. First is familiarization. First let's get the familiarization done. Then we will go for the rig up of the circuit and try to get these values. What will be the voltage across R1, voltage across R2, and what will be the current in my circuit. Okay. So from Ohm's law, the current I in the circuit is equal to V divided by R. So according to the circuit, the voltage is 10 volts and the total resistance in the circuit is 2.2 kilo ohm plus 1 kilo ohm, which is equal to 3.2 kilo ohm. So when we apply the Ohm's law, my current I is equal to V by R, which is equal to 10 divided by 3.2K, which tallies to say 3.125 milliampere. Now also we have to determine what will be the voltage across my resistance R1 and R2. So voltage across R1 can be determined as the current into the resistance R1. So current is 3.125 milliampere into the resistance value is 2.2K, which tallies to 6.875 volt. Similarly, voltage across resistor R2 is equal to the current in the circuit I into the resistor R2. So this is equal to the current 3.125 milliampere into 1K, which is equal to 3.125 volt. Now this can be verified by connecting in practically. So we have a DC regulated power supply and connected to it is the ammeter. So you can trace the circuit. The positive of the supply is connected to the positive of the ammeter. So this multimeter acts like a DC ammeter. The negative of the ammeter is connected to the resistor 2.2K. The other end of the resistor is connected to the resistor 1K. The 1K in turn is connected to the negative of the power supply. Now let's try to verify both the theoretical and the practical value of the current and then the voltages. So while using the DC power supply, your current knob should be in the maximum position, and according to the circuit, the DC voltage should be 10 volt. So just increase the voltage. And the ammeter, it should be connected in milliampere range. So switch on the multimeter and move it to milliampere range. Now first we have to measure the voltage across resistor R1, which is nothing but our 2.2K. So connect your voltmeter across resistor R2. So you have to put this multimeter in the DC mode. So now we can verify the ammeter reads a current of 3.18 milliampere and my voltage across R1 is 6.9 volts. So theoretically the current should be 3.125. So practically we are getting 3.18 milliampere. Similarly, the voltage across R1, theoretically it is 6.875 volt. Practically, we are getting 6.9 volt across R1. Similarly, we can check what will be the voltage across R2. So change the positions. So connect your multimeter across R2. You can see theoretically it's 3.125 and practically we are getting 3.16. Okay, so this verifies the Ohm's law, as well as we have learnt the usage of our regulated power supply and also how to use a multimeter to make it work like an ammeter as well as to make it work like a voltmeter.